what kind of concavity would there be normally if there was a minimum? Concave up. So the second derivative would be positive. So this is so stupid cool. So instead of making a sign diagram, that's the first derivative test, right? So to find local maxes and mins with second derivative. This is such an awesome flippant idea. If it's concave up, there's a chance there's a min. If it's concave down, there's chances of max. You can also, of course, have this weird shit here, so there's those weird little places where the derivative is freaky, But in general, that's where it's going to happen. So, let me see. Let me give us a problem here. Blah, blah, blah. Yeah, let's do something that's not too freaky. Let's see if I can... Ooh, this is going to be scary, Jeff. Yeah, sure, why not? Okay. So how do I find the critical numbers related to the local maximum?
Take the derivative and then set it equal to 0.
And yeah, that one, or where's undefined, but this is a nice function, and Liam's like, why would I even say that? It's a nice function. So of course this is just 3x squared, 26x. Now if you set that equal to 0, so x is 0, 2. So those are my critical numbers. Those are my possible maxes and mins. So you could make a little sign diagram and that, and isn't that a little bit gross? It isn't that horrible, but it's a little gross. I really don't want to do this, but I can do it. All right. So when the second derivative isn't horrific on its own, which it definitely won't be here, I'd rather do that. So the mistake people make when I say use the second derivative test is they find the critical numbers of the second derivative. That ain't got shit to do with this. It doesn't have shit to do with this. So tell me, if at this critical number it's concave down, that means that this is the location of a max. So all you got to do is take the second derivative and then plug these into it. See if it's concave up or down there. That's the second derivative test. So what is the second derivative? 6x minus 6. Don't factor or any of that shit. Plug in 0. You want to see what the concavity is at 0. That's all you care about. I know x is 1. Who gives a shit? I don't care. So when you plug a 0 and you get something that is less than 0, right? You get negative 0. Who cares? That means it's concave down, which means there is a max. Max at 0, 0. And f double prime of, where do you go? 2. 12 minus 6 is greater than 0. So that means there's a min. Please let this make unbelievably great amounts of sense. That's concave up. There's a min there. At the critical number, of course, right? So min at 2. 8 minus 12. Negative. So instead of doing the sign diagram, if the second derivative is easy, that's a quicker way to do it. If the second derivative was disgusting, I'm not going to do that unless the book or me tells you to do it that way. And you know me, I'm evil. So yes.
Are you plugging it into for the min and max? You're plugging it into the original function?
Oh, to find the points, you always plug it into the original. What am I doing here? Investigating concavity, so I'm going to plug it into the second derivative. That's why those of you who do this kind of thing is going to drive me a little insane. That's not work. That's a problem to solve, and that's not what you mean. What does this person mean? What does this person mean? What should they write?
F
F prime of frickin' x is 8x minus 7. You don't want to do this kind of thing to yourself or to the person granting your stuff, trying to follow along. You want to be nice to yourself and explain exactly what is what. Why? Because then you know exactly where to put stuff. It's already hard enough to remember where to put stuff. If you don't even label it correctly, I don't know what to do for you. Right? You're really making it hard. Does that make sense to me? I told you a while back, you got to really be careful. We're going to get to a point where you got to know what's what, and we've been at that point for a while now. So, okay, is that cool? That's the second derivative test, which I didn't purposefully not talk about. I just happened to not talk about it, and I thought, let me wait till somebody asks. We'll see what's up. Yes?
Can we get an example for 4b? Or something similar to 4b.
Oh, yeah. Okay. So what am I asking for there?
You're asking to show the following functions satisfy the hypothesis with mean values theorem.
Oh, so, I'm sorry, 4? So not 4.
Or 5, my bad.
Okay, 5. Okay. Whew. What are the hypotheses of the mean value theorem? So, seems like maybe you got to know these. What are they? No, come on. The function I'm given to work with must be two things. Continuous on A, B, and differentiable on... Doesn't have to be differentiable at the endpoints. It's too extreme of a requirement. So it's just really another way to say it, it's got to be a nice function. It can't do weird shit like teleport, and it can't do weird shit like kinky stuff. Kinky functions. Right? That's what it's saying, because that would make it possible for it to not do what the theorem says. This, obviously, if this was 0 and this is 0, then there should be somewhere the slope is 0, right? And there's nowhere, this doesn't balance on here. It's like, there's nowhere that the slope is horizontal. So why doesn't that meet the mean value theorem? Because the function doesn't even meet the requirements. So mean value theorem is like, I don't know what the shit's going to happen to that thing. It's freaky. I only work for nice functions. Okay. So, let's see. Okay, so I give you this guy. What is this guy's domain? And do I give you... Yeah, I do. -3 to 0, so. What's the only freaky place for this function? 1. That's not in this interval, so therefore it's a rational function. So we know that that's continuous on its domain, so it's definitely continuous on this, because the only place it's freaked out is 1. And it's differentiable on that, because there's a theorem a while back where rational functions are differentiable on their domain. Really good theorem to remember. Okay. The idea of mean value theorem is actually too nice to believe. And you guys are like, you say that kind of thing so much, I don't think you know what that means. But all it says is, get out of there, F of A. The slope as the crow flies between 2 points. If I have a function that does this, right? A nice function. This slope has to be the same as some slope somewhere, at least at one point. And this is a very... You can try to break it, but you're not going to break it. You can try to draw a function that is continuous and differentiable, so you can't do those things. And then you'll realize, there's no frickin' way to not have somewhere that their slope will be the same as just as the crow flies. So this slope is algebra. And of course this slope is calculus. So I love mean value theorem. It's calculus idea equals algebra idea. That's really what it is. So what 2 ways do we have to find the slope? We have good old f of b minus f of a over b minus a. And I'm going to set that equal to the other way to find the slope. And what are these points? What are we going to call them? C1, C2. So I'm just going to, these are my C's. So I want to set it equal to, what's the other way to find the slope, of course? Derivative. So I'm going to set it equal to f prime. See, this is the heart of mean value theorem. The slope at least one point must be equal to the slope between the 2 points, the 2 endpoints. That's the whole idea, the parallel thing. This picture is captured by this equation. So nice. So I have to do f of 0 minus f of negative 3 all over 0 minus negative 3 and set that equal to, now I've got to figure out what the derivative is. Go ahead and do this problem if you haven't done this problem yet. Figure out what the derivative is, and then put it over there and solve. See what happens. I almost don't want to record this lecture.
Alright, I got the derivative for that.
Put this somewhere else. Take the picture away. Put your picture away. So what's f prime going to be?
2 over x minus 1 squared.
Should be negative 2.
Negative, oh, my bad, negative 2.
Yeah, because you get derivative of the top times the bottom. All right, green, you're not going to work. Will red work? Derivative of the top times the bottom minus the top times the derivative of the bottom. So these are going to cancel, you get negative 2. All right. Quick side trip. You don't understand what I'm about to say, you're fine, but I just want to show this to people that might get it. Watch this. 2x over x minus 1, right?
Mm-hmm.
Minus 2 plus 2. Is that okay to do? Does it make sense why I would do that at the moment? No, but can I do that? Yeah, because negative 2 plus 2 is 0. And I can add 0 to anything I want to in the universe. I can add 0 to it. Yay, Jeff. That's basically what I just did. But now look at this. So I get 2 over x minus 1. And this is 2 times x minus 1 over x minus 1. So I get 2 plus 2 over x minus 1. This is the same, so this is this. And what's the derivative of this? 0 minus 2 over x minus 1 squared. Bam. And the reason that will work is because these are the same degree. Do you really have to understand this to be able to survive in math? No. But if you understand this, it means you got some more survival skills. Your tent will have not let too much rain in. I don't know, I went too far down that with that analogy. So down here, I'm going to let this equal negative 2 over c minus 1 squared. When I was a student, and still, you'll see on the answer key, I don't really put a c there, I just leave it x, but it's something in between, in this case, negative 3 and 0. Now try to keep going. Keep going with that. What's f of 0? What's f of negative 3? This is just normal old slope. Good old algebra slope. y2 minus y1 on the top. What kills me, again, my intent is not to make you feel like a horrible person. My intent is to show you what's killing me about this class is a lot of us in here don't have the skills to work with this. This should be the easy shit. But a lot of us write that and then we're like, what? You could even just cross multiply. I mean, that's how you get to here, right? You could FOIL this out, select the 4 over, refactor it. I think that's what I did on the answer key. Or you could just do, square root plus or minus, of course. 1 plus 2 is 3, 1 minus 2 is negative 1, and which one of those is the answer? Why? Why not 3? It's not the flipping interval. Yeah. Cross through circle, so I can see that we eliminated that option. So that mean value theorem is another one where once you get the idea, you should be like, oh good, give me many of those. Because I can just sink my teeth into this. I don't know if you know what I mean when I say that. There's some problems that are like, and then there's some problems like this, like, do it raw. What are you doing on number 6 on the practice test? What's going to be used there? We have to check first before you use this thing
You
that I
have
haven't.
to check if it equals, check if it doesn't come to either 0 over 0 or infinity over infinity.
If it does do that, if it's of those forms, if it's of the form 0 over 0, infinity over infinity, what are we allowed to use? L'Hopital's rule, thank God, right? And 6c is an example where we didn't have to use it. We did that before, we factored. But those of you who hate factoring cubes, you now can just take the derivative, which kicks ass. The only mistake people normally make, besides not taking the derivative correctly, is like that last one. Let's look at that last one. Well, as limit as x goes to 2. What form is that in? Yeah, so it's in the form 0 over 0, so I'm allowed to do this. If it was not in an indeterminate form, I shouldn't have to do anything. I can just plug it in and get the answer. It's going to be either some finite number or some kind of does not exist situation. Okay. So, all right, so the first step is all good. Use L'Hopital's. And what does L'Hopital's say?
We change the derivative of the...
Yeah, the limit of the ratio of two functions equals the limit of the ratio of the derivatives of those functions. I'm not doing quotient rule. Good God. So L'Hopital's is all about the ratios of two functions and the ratios of their derivatives. So this derivative is easy. I'm just going to do it. So the mistake people make is they'll do another derivative. Why is that a mistake, to do another derivative? Because right now it's determinate.
Yeah.
So if it's determinate, L'Hopital's rule says, I might not work anymore. It only definitely works if it's indeterminate. What should the answer be? Now if I plug a 2 in,
It should
plug a
be...
2 in.
It should be
12 over
2.
2, which is 6. But if let's see, if I do another L'Hopital's incorrectly. So this is wrong. This is wrong what I'm about to do. This would be 6x over 2. So we end up getting the same answer, luckily, right? Well, that's a bad example. But these are nice functions. They normally would be like, we'll play along. But in general, that's why I said it the way I did. L'Hopital says anything could happen. You might get the right answer luckily, or you might get the wrong answer because I don't work for sure unless it's indeterminate form. Yes?
You keep taking the derivative until it's...
Until it is determinate. So if right here it was still indeterminate, then I could totally take another derivative and know for sure that the answer will be the same. The minute you take a determinate, take a derivative when it's not indeterminate, anything can happen. I mean, what do I get if I take one more derivative? 6 over 0, and then your answer does not exist. Now you're really wrong. So that's, L'Hopital's is like, I only work for sure if it's indeterminate. And one other thing, it only works for sure when you have a ratio. So like number 6b, what's the immediate thing you can do there?
Check to see if it equals anything, but I think
Since
this
it's a
is...
negative power, you can say...
Yeah, even if it wasn't, you would force it to be a ratio. If it's... So, I don't know if you guys did any of the reading in that section, but another indeterminate form is 0 times infinity. Because what's 0 times anything? And what's infinity times anything? Infinity. So what's 0 times infinity? Oh, shit. Immovable object, unstoppable force. So then it all depends on who's going to which thing faster, which is why L'Hopital's makes intuitive sense. It looks at the rates of movement. Which one's getting there faster? That's why taking the derivatives makes complete sense. I like that. I saw a few light bulbs. I don't think I've said it that way, but that's an overview of why it makes sense. There's another indeterminate form which is kind of freaky, 1 to infinity. Remember, these are forms. These are not... So what does this really mean? Whatever is in here is going to 1. Does it ever get to 1? No. And whatever's up here is going to infinity. It never gets there, of course, right? So what's 1 to anything? 1. What's anything to the infinite power? Infinity. So again, that is actually a really weird indeterminate form. Okay, and as long as you can write it as a ratio, L'Hopital's will come in and save the day. So remember, I happen to make all 3 of those start off in an indeterminate form. You know me. You know I'll probably give you a limit that you'll get the answer if you just plug the number in, but several people will just take derivatives and they will get the wrong answer. So you first check to make sure it's in an indeterminate form. Okay.
One of the first problems in 4.4, the indeterminate forms.
Which one, sorry?
It shows an indeterminate power. I think it's the first assigned problem in 4.4.
Oh, okay. I don't remember which one that was.
3.
3, okay.
Actually 4.
4, there you go.
4a shows an indeterminate power. Would you just take the limit of the exponent and the base?
How did I do derivatives of like x to the x? How would you do the derivative? And just hang out because it's related to this question. Just take a what? What's the best log to use? Natural. Why is it the best log? Because it's got the fewest letters to write. And its derivative is really nice. You can do log base 2 if you want to, but then you have that natural log of 2 extra bullshit running around. So if I do natural log, I get x natural log of x. Take derivatives, implicit stuff, right? You remember this stuff?
Yeah.
All right. So it seems like a good thing to think about trying when I have something with a power is to take natural logs. So for example, if I have, let's do an actual problem. Where are you, problem? There you are, problem. Here we go. I love this. So here's 57. It says limit as x goes to 0 from above x to the square root of x. So here's what I would do. Okay, so I'm working with this function, right? So then I take
Take natural log.
natural logs. Okay. Now if I find the limit of this, so if the limit of this was 2, then the limit of this must be e squared, because if I find the limit, I'm finding what natural log of y goes to. So then what would y go to? E to that. I've got to resolve it. Okay. What's the limit? What form is this in as x goes to 0? What form is this in? As x goes to 0, what does this do? Goes to 0. What does this do? It goes towards what? It does not exist, but in what way? What's natural log look like? Sure. So what's it doing as x goes to 0? It's going to negative infinity. So I have 0 times some kind of infinity. If you remember, that was one of the indeterminate forms. Now look. Here's what you do. Is that a ratio? No. So let me look at this. Where'd you go? So you just forced it to be a ratio, and then L'Hopital's can help. So you have a choice. You can either force the x to the 1/2 down, or you can force the natural log of x down. I think by my facial expressions, which one's the easier one to push underneath? X to the 1/2, because if it goes down, what's going to change? If I push this down, it's going to become x to the negative 1/2. That's all, right? That's what negative power means. It means I want to be on the other side. That's the real simple way to look at negative powers. I want to be on the other side. So if it's fine up here and I put it down there, it's like, I don't want to be here. So what form is this in now? It should be simple, because this used to be 0 times infinity. Now if I put 1 over 0, it's infinity over infinity. Which is, L'Hopital's go, I gotcha. So that's what you do when you have one of those straight line problems and it's some kind of weird indeterminate. You take one of the two, whichever one's easier. The one I gave you was easy. One of them was a negative power and wants to go underneath. In this one, you just move the one that's got a nice normal power to it. You don't put natural log of x to the negative 1. That would suck. And then what can I do now? Yeah, I can apply the hospital. It turns over its grave every time. When do I use the hospital? When you have hurt yourself. So this becomes what? Way too many people are telling me this. Way too many people. Which means like 3, but that's way too many. Holy shit. If that were true, why would we have natural law? Why would it exist if it's already just 1 over x? All it is. No. What makes this true? There, now it's true. You can't just replace 1 over x with ln or ln with 1 over x. Well, that made that easy, Jeff. Yeah. You got to the wrong answer fast. All right, so natural log of x, the derivative is 1 over x. What's the derivative of this dude?
Negative
1/2.
To the negative 3/2.
I love it. Now simplify this. Watch what can happen. Okay, let me see if you guys get this. That wants to be underneath. That wants to be up top. And that wants to be up top. It's 1 over x, so the x goes underneath. And then I reciprocate the things on the bottom. Divide by a fraction and multiply by the reciprocal. And then what's going to happen here?
You can.
What's x to the 3/2 divided by x?
It's you get
What do you do with powers when you divide like bases? Subtract. 3/2 minus 1 is
1/2.
1/2. Is that still indeterminate?
No.
Nope. When you plug a 0 in, you get
0.
0. How do you check that? How do you check it? No idea what accent that is. How do you check that the limit of that is 0? What do? You graph it, right? Come on. You graph it and you make sure it's actually going whatever the weird shit is doing. It should be going to 0. I like it. Somebody's checking right now. I love it. It's exactly what you should be doing. You should be like, whoa, does that make sense? What the shit can I do here? You have that stupid, powerful, expensive tool. Some of you overuse it. But some of you don't use it at all. Doesn't make any sense.
We do a problem like 45 on the practices.
Yeah. So that's number 7, right? 45. So 316. Oh, okay. So we got that there. So this one says show that 3x plus 2 cosine x plus 5 has exactly 1. Well, they should have said it like this. This book sometimes is stupid. So the way they give an equation is it has one answer, or the function has one real root. Pick one way book. What is a root? What does the word root mean? In Australia, it means something bad. Going to find out. Oh, I went to Australia. I went to a footy game. And I looked to the woman next to me and said, "Who are you rooting for?" And her husband looked at me like, "What are you asking my wife?" You can imagine what root might mean. Here, root for a team means one thing. Root in math means another name for I think somebody said it. 0 is another name for the 0 for the function, which is another name for the x-intercept. So, even if you have no idea what the shit to do with this, what's a really good first thing to do? Considering what class we're in.
Check derivative.
Take a derivative. Right. So let's take a derivative. What do you get when you take the derivative?
We get 3x, just 3 minus 2 sine x. That's it.
I like it. How a function that has only one root. One way for that to happen is like all the curves are above or below, you see, except for one place. But another way, an easier way for that to happen is if it's always increasing or decreasing. If it's always increasing or decreasing, it's going to have one root. The only way you can have 2 roots is if you go through and then turn and come back. Especially because what kind of function is this? It's a nice function, right? It's continuous, differentiable. It's a nice function. So it doesn't have any transportation or like cusps or anything. Right? What do you mean by transportation? So what about this? What about 3 minus 2 sine x? What's the most negative this could be?
Or 2.
Negative 2, right? So the smallest this derivative can be is what? So this derivative is always positive. Now, the derivative of e to the x is always positive. Does it have any roots at all? Nope. So what else do you need? You need one more thing. In order for it to have a root, it's got to have a point where it is, and a point where it is. So one point where it is negative, and another point where it is positive. If you could find that, coupled with the fact that it's always going up, then it's got one root. Does that make sense? So, this is what people hate about calculus, and it's unfortunate, because it should have happened to you already in pre-calculus, which is the idea of, you never showed me a problem like that, Jeff. And it's because there are ideas, and there are nearly an infinite way of using those ideas. So how do I test to make sure you understand an idea? I give you a situation that you can use the idea in that isn't like what you've seen before exactly. If you can do that, then you understand the idea. So this isn't just, well, if this got a problem, so do this. That does happen every now and again, right? That's nice, that recipe bullshit. But that doesn't really mean that you understand what's going on. So hate me as much as you want to, but every problem on that test is related to an idea that we have discussed. Period. Right? Okay. Let me go ahead and give you guys the answer key. Just to remind you guys, what was it? I said this to you earlier. I should have kept notes. Which problems can we forget about again? On number 7?
We can forget about numbers 53 and 57.
57, 58, 53.
And
59. So it's 45, 61, and 63. So I'm going to have all those on here, but those three, 45, 61, 63, those are the only ones you have to worry about for this next test. Oh man, this is a two-parter. Oh boy. Okay, do it all at once. Thanks. Should end up with 2 papers, right? One is 2-sided, one is one-sided. I think this is, we only did the one quiz since the last test. Is that true? Yeah, which means it stays the same side around. Yeah. So it's like a problem. If it starts off below, it's going to still be below afterwards. No. There won't be a maximum in here at all. It goes like this. It goes Now remember, when I do this, I'm talking about the derivative. What's the function doing? Down, rest, down. So I want to sort of the function I'm looking at does, and what are you looking at to make this f prime? So what does f do though? Goes down, rests, goes down. That you're telling yourself what f does. So this is where f goes down, and then that must be. This won't be either. Cool. Yeah. Now you see why I don't give that key out at the beginning. Try to trick people into staying and getting something out of it. Yeah. Oh, good. Somebody else has asked me about that.
Do you use the numerator or the denominator?
Yes. In general, because critical points occur where? No. Critical points occur when the derivative is 0 or undefined. So I do 0 or undefined. Bottom is where you figure out if it's undefined. Top is where you figure out where it's 0, right? Because how can a fraction be 0 is if the top is 0? When is it undefined? When the bottom is 0. I don't know if you guys ever saw the OK and the NO. It's my algebra students have trouble remembering when it's okay to divide and when it's not okay. This is undefined, this is okay, this is 0. Anyway. So somebody else had that same question, I think. Let's see. So what 2 points do I already know I'm going to check to see where the absolute extrema are? Negative? No. What 2 inputs am I going to use already? Just to test for the absolute extrema. The endpoints, negative 11, 0.5. I got to now find any points in the middle. Right? So that means taking the derivative, and of course the derivative. Once you learn L'Hopital's, you start doing the wrong thing at the wrong time. But here I've got to use quotient rule. I'm taking the derivative of that function.
Let me find that.
So it'll be derivative of the top times the bottom
Wait, that's
minus the top times the derivative of the bottom. All over the bottom squared. So 2t squared minus 4t squared is negative 2t squared. So is this thing ever undefined? No, not with real numbers, because the bottom is at least 1. So it can never be 0. Is this derivative ever 0?
no.
What would make this fraction 0 if the top is 0? Plus or minus 1 are both 1 and negative 1 things I have to consider. Let me write that out like this. Which one can I throw out? 1, because it's not in the range. Right? It's not in this interval. And now you just plug in. You put them in old calculator. What's S? S of negative 11. What's S of 1? Negative 1, sorry. And what's S of 0.5? And you see who wins the 2 prizes. Is that cool? That's absolute extrema. They're awesome. Check the endpoints. Check the critical points. See who wins. Next. Don't do a sign diagram. Don't do a second derivative test. No need for that. It's an absolute extrema. It should be easier to tell. Who's in first place? The guy that came in first. Who's in second, third, fourth? Oh, shit, man. All right, let's look. Who came in second in the 1988 Boston Marathon? I don't know. I know who came in first, so that's why that's an easier problem. The local maxes and mins are all the other places. Oh, God. Oh, they're on the answer key you got.
Okay.
Doesn't matter.
Okay.
Sorry, buddy. Sorry, Liam. Didn't mean to steal your thunder.
The lightning and the thunder.
Oh, okay. Oh, okay, I see.
Yeah, remember plugging back into the original function to see who's tallest or smallest. The derivative won't help you there. Yeah.
For number one, how do you do like the second part with the interval of x values that make the
Oh, good. All right. There's another question that nobody asks it. Oh, that's too bad. Somebody stayed just signed in, looking up their zodiac. Okay, weird. Should I send an email to the president using your email? Whoever stayed is signed in to the computer? You guys are like, hey, we don't care, man. I don't blame you. All right. Oh, yeah, this room doesn't have my. Oh, well. So, watch this. So, before I go up there, for this problem number one, blah, 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 blah. So, the function is natural log of x plus 3. You should get that your linear approximation comes out to be, what was it, x plus 2? Yeah. So if I want to find the interval of x values where the amount that I'm off by is at most 0.01, yeah. What the shit does that mean? I want to know all the x values where if I do this, it's only different from this by at most 0.01. Okay, how do I set that up, what I just said, in mathish? So I want the difference between these. I'm missing something to be less than 0.01 to make this real, and this is why it's really good that we did 2,4. This should feel very familiar. Right? I mean, that's the distance. That's the true distance between them. I want the distance between this, the function, and my estimate to be at most 0.01. Does that make sense? That's how I captured that idea mathematically. Now, does anyone remember how to rewrite something like this? How do I rewrite this without an absolute value? And so many guys are like, no. I mean, how do I capture this idea in a different way without an absolute value?
-1.
Yes. When I teach this absolute value with a less than, I call that a stay close to me, a sandwich. Greater than is a restraining order. Stay the shit away from me. Right? So this is a sandwich, stay close to me. So how do I rewrite this one? Same way. It'll be natural log of x plus 3 minus x plus 2 less than or equal to 0.01 greater than or equal to negative 0.01. Oh my God. And then if I add this to all sides, I'll get x plus 2 minus 0.01 less than or equal to this less than or equal to x plus 2 plus 0.01. No, yeah, and then you can put these in volume. So here's what we do. This is really complicated. Focused AF. Okay. I always do get that. That's a yeah, cool. Thank you. Okay. So now watch, this is kind of cool. So this is I gotta turn my camera around anyway, so this is a floor, this is a ceiling. See, that's a beautiful way to look at it, containing this. So visually, the answer is going to be, when is this line on the graph, or this curve, contained between these two? That's beautiful. I have recast the question into a purely visual question. So if I graph the floor, which is a really awesome statement to make. What do you want me to do with this? Graph the floor. And then here's the middle dude, natural log of x plus 3. That's the guy we're trying to catch. And then here's the ceiling. This one's a little bit grosser than I probably meant to make it. I should have made it 0.1, but oh well, too bad for us. You'll see what I mean. Everybody hit, if you're trying to play along with me, hit zoom 6, so we all start with the same picture. Right, you're not getting less bright.